Hello everyone, we are final year project group 8. Our project is Intelligent Cleaning Robot for Domestic Environment, a simulation in Webots. Our project supervisor is Professor K.A.K.B Jayasekara. Background: cleaning is the most common household task performed in our day-to-day life. Cleaning the floor and tidying up the kids' room is usual in homes that have kids between the ages of 2 to 5. Even though most people do work from home, cleaning the floor while balancing your work and life will be tiring and difficult. The best solution is a cleaning robot. Now let's see the problem statement we have identified. When you have kids or pets in your home, it gets messy frequently. So when cleaning robot starts cleaning, it has to face many small obstacles such as small toys, waste and lightweight objects. So it avoids everything and cleans the rest area. Or it will drive over some of the small objects and get tangled with them. We identified this problem to study more in our project and came up with an idea to improve cleaning performance. Now let's see the objectives of our project. First, develop an algorithm to map the environment effectively and classify small objects for the kids' room as toys, waste and other, and for living room as movable or not. Second, plan the paths and navigate for cleaning by considering above intelligent algorithm. Third, modeling and simulation of the cleaning robot to tidy up kids' room and clean efficiently in living room. This is the project scope that we have identified. Navigation of robot while cleaning. Use sensor data to do simultaneous localization and mapping. For kids' room, classify small objects as toys, waste and other. Then move them by pushing into separate areas to tidy up the space. For living room, we move small objects to the side that is already clean by pushing and carry on the cleaning. Avoid obstacles while cleaning. For those identified objectives, we have done our literature review. We have referred research papers to identify and study about the technologies that we can use to develop our robot and to get an idea about the existing work and research gap. Now let's see the design of our cleaning robot. We have two fixed wheels and one caster wheel and two side spinning brushes were mounted under the robot. Camera and LiDAR sensor are located in the upper side. Also, we have this special shape to support the pushing of object and it is coated with the rough coating. Now let's see the simulation. For simulation, we are using the Webots robot simulation software. This is the environment that we modeled for kids' room. This is the living room. We are following the state transition diagram for living room. When a robot starts moving, it follows the S pattern to cover the area and move forward. When an obstacle is detected, it will follow the obstacle avoidance algorithm. When small objects are detected, it will take the decision whether they are movable or not based on their size. We assume all the objects that can capture into a 40 by 40 pixel frame are movable. If movable, then they are moved to already cleaned area and comes to the previous position and continue moving forward. This is the state transition diagram for kids' room. Here, also robot moves, avoid obstacles and follow the map as mentioned before. When small objects are detected, here we classify them as toys, waste and other. Then we move them to predefined areas separately. Then again comes to the previous position and move forward. Now let's see the generation of map. The purpose of generating a map is to identify the area that it has to clean. When robot moves to a new environment, it will create a map of the environment in the initial run. It will include the barriers in the environment such as walls, sofa and cupboards. After that, for every run, it will reverse this map to support the localization of robot, path planning and navigation. To generate this map, we are using robot operating system library called ROS Gmapping library. It uses LiDAR-based simultaneous localization and mapping. We use ROS Neotic version with the Ubuntu operating system. To visualize the map, RVIS, which is ROS graphical interface, is used. This is a speed up video of the process. Navigation. In this video, we show S pattern navigation of our robot We follow this pattern to move around while cleaning. Also, obstacle avoidance and object moving is performed with this S-pattern algorithm. This is a speed up video of the process. This is a simulation of kids' room. Here we show how robot pushes object to the dedicated sides and comes back to the original position. For toys, waste and others, we have defined separate areas. This is a simulation of living room. Here we shows how robot pushes object to the sides that is already clean and carry on cleaning. These videos are also speed up videos. Results analysis. For image classification, we modeled the convolutional neural network. It shows a validation accuracy of 97.65 and a validation loss of 7.83. For 30 epochs, we have taken validation split as 0.2. This is the confusion matrix we prepared. Our classification has 17 classes, which is toys and waste. We have categorized them into 5 to prepare this confusion matrix. Here, values in the main diagonal demonstrate the correctly classified objects. Model shows a 0.82 coins copper value, which is an indication of a good strength of agreement in our model. Here shows sample images we used to train our model. We have taken 5,100 images. These are the sample images we used to test our model, which taken from our robot's camera in simulation environment. This is a video of testing few images with the trained model. It outputs the probability value for 17 classes. Then output is taken related to the highest probability. Here we have compared our navigation algorithm, which is S-pattern, with a robot who follows a random navigation algorithm. We have identified that S-pattern approach is effective. Here we show the overall cleaning performance of our robot. In the left side of the screen, our robot moves following S-pattern. In right side video, robot moves following a random navigation approach. So we have validated our robot's performance is effective. Conclusion. The simulation environment and scenarios for we modeled has limitations. Obtaining sensor data accurately was a challenge, but we were able to make adjustments accordingly and perform an effective cleaning performance. As future work, we can say increasing the scope of the simulation and do hardware implementations. That is the end of our demonstration. Thank you.